Now, can I subtract them at this point? Yes, right? Because you have the same denominator. So I need to do this and take away all of that, right? So it's real important, again, that minus sign is going to have to distribute through to both of those. So let me see if I can do this in one line, so, or without having to put the parentheses. So I'm going to leave the first one alone. Then I'm going to subtract this. When I subtract that, it has the effect of changing the signs of both of them. I'm skipping a step there. Is that all right? I'm not showing the parentheses this time. I'm just saying this one, the parentheses aren't going to matter. Here, the parenthesis on the second one, the negative would distribute through and change the signs of both of those. And then over my common denominator. And final step, maybe, is to collect like terms. So these two are like terms. 3x squared minus 2x squared is just x squared. And then here and here, that's what? 17x. And then all of that over my two factors here. There is one more thing that I would want to look for, and that is, do y'all see up here I could pull a GCF? Do you see these both have an x? I could pull a GCF out of the top. And the reason I'm doing that is because I just want to make sure that, like, what if this was x plus 3, right? What if it was x plus 3? It would cancel, right? Or if it was x minus 4, it would cancel here. So I do want to at least address that maybe that could happen. Since nothing cancels out at this point, we're done. Okay. What do you think? You all right? Let's see here. Today is the 5th. Again, the sign-in sheet's coming around. Sorry that it's not updated. I'll get that updated as soon as I can. All right, we're going to continue grinding out. We're just grinding problems now, right? Let's do something like number 64. 64? Yeah, I guess so. X over x minus 3 minus, oh good, x plus 1 over x squared plus 5x minus 24. Subtraction between two fractions, right? Subtraction between two fractions. So what I'll do first, I'm going to look at this. I'm going to be like, wait a minute, hold on. This is a quadratic, right? This is a trinomial. I'm going to try and factor that using AC method. All right? So let me do that. And I'm not going to show my work. I'm just going to do it. So from here to here, I'm leaving a space in front of this fraction so that I can come in here in a minute with my LCD. So this will be x, and I guess it's minus plus 8 minus 3? So everyone understand I'm not showing that step, right? I'm just doing that factoring in my head. This gets factored to be this. Now, the reason I'm doing that is because if by looking at it here, I can see that these both have x minus 3, right? The only thing that this one doesn't have that one does is the x plus 8. So I just need to make an x plus 8 appear on the top and bottom here. So here I'm coming in with that hidden 1. That's why I left a space in front of this. I kind of knew where I was going here. So I put x plus 8 here, x plus 8 there. Any questions there? All right, now, whoa.
I'm good.
All right, is your laptop again?
Yeah, it's fine.
Okay.
This thing is taking a lot more pains than you might think.
All right, I need to multiply this out, right? Multiply this out. So on the top, I'm going to do x plus 8. There's two terms times the x, which is just one term, so I don't need a parentheses there, over the common denominator, which I am not going to multiply out. then minus, and then here, fortunately for us, there's nothing for us to do. And the whole point of that was we now have the same denominator, right? What now? Distribute through this top, right? Here, here. So x squared, let's see if I can do this fast. X squared plus 8x, right? X squared plus 8x. Then I still need to do what? Subtract this thing, right? Which means this minus sign is going to hit both of these, making them both negative, right? Minus x, minus 1. All of this is going to be over the common denominator. Questions there? Okay, x squared plus 7x minus 1 on top over x plus 8 times x minus 3. Yes?
Couldn't I simplify this further?
How?
I just have a sneaking suspicion I should probably should.
So, well, one thing I would say is that this right here is a trinomial, right? So maybe it factors, right? Maybe it factors. We should address that. We need to look for it to see if it does. Let's try it, AC method. Take the 1, multiply by negative 1, we would get what? Negative 1. And then the number here is 7. And now you have to figure out if you can come up with two numbers that multiply to be what? Negative 1 and add up to be 7. You're not going to do it, okay? It's not going to happen. Well, you're not going to be able to find nice whole numbers that do it. There may be numbers that do it. They're just not going to be easy to find.
I would just feel like an idiot.
Well, no, because you need to check this. You need to know that this doesn't factor. Because if it did, it could be that it cancels, right? So you want to try it. Now, if you get to this point and you're just like, well, it doesn't. So there's a difference between that and, was this the problem we had earlier? Right, where I asked you, let me know when you're done. There's a difference between you not being able to find the numbers, but they actually do exist. Like, what were the numbers here? It was 12 and negative 2. Negative 12. Was this a negative here? I don't remember. It was negative. Okay. Remember? So there's a difference between saying that, yes, there are two numbers, you just couldn't figure out what they were, and this situation where there are no two numbers, right? You're not going to find them.
I remember my teacher said that like if the number on top is like smaller than the number on the bottom, you're gonna have to use fractions.
Yeah, so the idea is that this number here, right, to multiply to get negative 1, there are only what, two options? You can do, well, 1 and negative 1, right? And those there's no way those are going to add up to be 7. Now, the thing we're not doing here is we're not thinking about fractions, are we? Are there a lot of different ways that I can multiply two numbers together and get negative 1? If I'm looking at more than whole numbers, just other numbers like fractions, can I get negative 1 a bunch of different ways? Yeah, I could do like 80 times negative 1 over 80, right? That would work. Multiply these two together, you get negative 1, right? And I could do that for anything, any number. 40 and negative 1 over 40, yes?
So it should be aware of the possibility that it could factor.
Yeah, this may factor. This may factor, just not over, we say it wouldn't, it's not factoring over the integers. In other words, these are not going to be nice whole numbers, okay? And so I can stop looking because these two factors are whole numbers, so I guarantee that this is not going to cancel. Nothing's going to go away here. So we're done.
Okay.
All right, I'm going to do number 74 now. This was by request. One of your classmates accidentally tried to do the whole homework assignment. Who was that? You're better off for it, right? You're better off for it. It's good practice, right? How did you feel doing it? Did you have you remember doing this before? Okay. All right, so let's see. This one right here, 1 over h, weird. Okay, we have h in here now. And then bracket 1 over x plus h squared minus 1 over x squared. All right. So let me just preface this problem with a little bit of background for you on this. This expression that you see right here, it comes from calculus. All right. It comes from something that you do in calculus called finding the derivative of a function, which is one of the most fundamental things in Cal 1. It's actually the thing that you do in Cal 1, is find the derivative of a function. And to do that, you must be able to do this algebra, right? So if you're wondering, like, why, where is that expression coming from? That's where it comes from. So, I told y'all, like, don't get fixated on all the stuff we're doing in here. Like, why am I doing this? I like to think of it this way. What we're doing in a class like this is learning how to use the tools, right? It's like, hey, here's how you use a hammer. Here's how you use a table saw. Here's how you use a sander. Like, I'm teaching you all these tools. And when you get to calculus, you actually get to build something. You get to do something with the tools. But if you don't know how to use the tools, you're not building anything. Make sense? All right, so let's see. What the heck are we supposed to do here? We're supposed to simplify this, right? Simplify this. So let's take a look at, first, just what's in the brackets, okay? I just want to focus our attention on this and not worry about this right now. So let me bring that over here. All right. I need to get a common denominator in order to subtract these, right? I need to get a common denominator to put these together. So I would like for you to you don't need to write this line down. I just want to really make sure you understand what this fraction over here means and what this one means, right? This means this, and this means this, right? So to get a common denominator, what I have to do is, on this, you're not raising your hand, right? Okay. On this one over here, I need to multiply by 1, right? Something over itself. And over here, multiply by 1, something over itself, so that they have the same denominators. This one here is going to be whatever this one has that that one doesn't. So what is that one missing that this one has? X squared, right? I need x squared. I need 2 x's. Actually, I think I want to do it up here instead. So I need an x squared here and an x squared here. All right, what does this one have that this one doesn't? X plus h times x plus h. 2 of them, right? 2 factors. I need both of them. So I'm going to put that over here as, what, x plus h squared? So I'm a little worried about my wife right now. My wife works 24-hour shifts. So she just got home. I mean, she's used to it. She only works like 4 days a week, four days a month or something like that. She's in the medical field, yeah. Anyways, but normally, she comes home and she gets her little doggy and goes to bed, right? And they go to bed together. And they've been doing that for 10 years. So this is her first day coming home alone to an empty house. Huh?
She does that 4 times a week.
She does 24-hour shifts, like 4 to 5 a month. Yeah. Yeah. Sometimes, it might be more like 5 or 6, but it doesn't matter. So she just texted me, so I was like, just making sure she's all right. All right. This is going to be just multiplication, right? We need to multiply these two together, multiply these two together. All right? The tops are pretty straightforward, right? Just 1 times this is x squared, right? Nothing fancy there. The bottom, let's not multiply the bottom out. Do y'all see that in every problem I've done, when we got to the common denominator, I actually never multiplied them together, right? I've just left them alone. In calculus, that is usually the case. You don't try and make the denominator more complicated. Just leave it completely factored out. And then over here, we're going to do 1 times this, x plus h squared, over x squared times x plus h squared. Okay, they now have the same denominator, right? So I can put them together. Equals, all right, let's look at the denominator. That's going to be the common denominator. And then I have x squared, that's this, and then minus that. Now be really careful here. You cannot pass the negative through yet, right? Why? Because passing the negative through would be the same as multiplying by -1, right? Multiplying through. But order of operations says that exponents come before multiplication. So you would have to first do this thing squared before you could put the negative through. Understand? And that's what we're going to do on the next step. This is not the final answer, all right? There's more, and things are going to cancel, all right? So continuing, let's go right here. This is x squared minus. Now, I'm going to do a set of parentheses here. All right, big set of parentheses, because what I'm about to do is square this. Okay, I'm going to do this right here. That's x plus h times x plus h. You are going to do that exact multiplication so many times in Cal 1 that you're going to get to the point that you just have it memorized, all right? But for now, let's just do it. It's this here, this here, this here, this here, right? That's what we're doing. So we get x squared on the first multiplication, x times h on the second multiplication, x times h on the third multiplication, and h squared on the last one. So that's just me doing the good old FOIL expand, right? Are there any like terms there? xh and xh. Add those together, we get how many of them? Two of them, right? So I'm going to put that here. I'll do it in purple so it matches that color over there. So this is x squared plus 2xh plus h squared. We good? We're not done, but you all right? Now you are allowed to distribute the negative through. Now you can. So I'll do that up here. X squared minus 2xh minus h squared. That's me distributing the negative through the purple. The bottom, I'm not doing anything. All of that, do you see what happens? All of that, we actually do have one good little thing happen here. What is it? The x squareds go away. You see that? The x squareds go away. Y'all all right? Okay, we're not done. We're not done because remember I said, let's just look at all this and take that over there and figure out what it becomes? What have we still not addressed? The 1 over h that was sitting in front of all this, right? So I'm ready to come back over here now and address the 1 over h. Okay, so this is equal to 1 over h bracket. Okay, what did this turn out to be? Negative 2xh, oops, that's a weird h. 2xh minus h squared, right? Over x squared times x plus h squared. Close it. What happens if you get one little thing wrong? It's all wrong, right? I mean, that's just, I mean, there's a give and a take, right? There's a give and a take. When you're in a field like STEM, math, physics, chemistry, right? Engineering, right? It's very precise, right? There's a give and take. You've got to get everything right. If you make one mistake, it's all off, right? But the good news is that there should only be one way to do it. Like everyone should get the same answer. It's not like writing a paper, right? Where it's going to be someone's subjective opinion of something. So, you know, this. All right, now how does this 1 over h affect everything? Well, I can multiply it through because this is like a fraction. What I'm really doing is I'm taking this fraction and I am multiplying, right? This is implied multiplication, multiplying straight across. So what happens if I multiply straight across? 1 times that changes nothing, right? And h times that is just going to be sitting on the bottom as an h. Let me do that. We're almost there. We're almost there. Okay, h, then I still had x squared, then I had the x plus h squared. How am I doing on time? It feels like I've been,
10,
yeah,
9:50.
9:50. Yeah, 9:50. All right. I don't know about you. I was pretty sluggish when I walked in here. I'm feeling good now. You? Any better for you or no?
Yeah.
Or more sleep now? All right. Raise your hand if you see the step. Raise your hand if you see the step I need to do again, or next, I should say. Okay. Hold on. There's something that you can cancel from the top and bottom. What is it? Okay, so you can do what on top? Say it. You can take out an h on top. So factor an h out, right? You can factor an h on the top. These both have an h, right? So you're doing a GCF, aren't you? Pulling the greatest common factor. You're pulling an h out. What would be left if you pulled the h out here? Minus 2x. Minus, you pulled an h away from this, so you have just one h there. That fair? That's a legal move. But that's all on top of the h times the x squared times the x plus h squared. And now, what? Your h's can go. And you're done now. That's our answer. That's the answer. All right, so let's see what else we got here. Yeah, I'll do something like that. So I need to decide here. And a class like this is tricky because I would actually like to show you like where this is coming from and why we would need to do this, right? I'd like to show that to you, but the cost of that is that I have to eat up time. In a class like this, we have to get to a certain point, right? There's a goal at the end of the semester to get somewhere. But I think this is probably important enough that I'm going to show it to you. Now, the only reason I'm doing this is to give you some sense of like there's a reason for this, right? Like instead of you just sitting there like, what in the world am I doing this for, right? So I'm going to try and explain to you right now exactly why that exact problem we just did would be necessary, all right? And it's going to actually get you to look a little bit into the future at Calculus 1. It's not going to require any special math or anything. It's just a concept, all right? First of all, do you all know how to find, if I give you 2 points, x1, y1, and we're going to review this later too. If I give you 2 points, do you all know how to find the equation of the line through those 2 points? You should have seen it. That's the slope. Okay, so if you can connect a line between those two, right? The slope of that line would be y2 minus y1 over x2 minus x1. That look familiar? Yes? Yes? That's how you find the slope of the line between those two. What about the equation of the line? Well, the equation, there's a formula for that. It's called the point slope formula. So once you find this is a number, you put it here, and then you can use either one of those points to come up with the equation. I'm just reminding you, we're not going to go through this. Don't worry if you don't remember it all. This is the one I want you to think about right here. This gives you the slope of the line between 2 points. Fair? Where does that come from? We draw a right triangle. This is your rise. This is your run. The rise is the difference of the y coordinates. The run is the difference of the x coordinates. The ratio of those two, rise over run, is your slope. Okay, that's where that comes from. Now, in calculus, what we do is this. We take a function like this. We pick some point, some arbitrary point. I'll call it x. Then we pick a second point right here. And I'm going to call that point x plus h. What it is it's this x value plus a little bit. That would move it to the right, right? If I added a little bit to that number, I should be over here. So like if this is 3, and that was 3 plus 1, that would be 4. Yeah? Then in calculus, what we do is we say if we connect these two with a straight line, what's the slope of this red line? Right? If we connect those two. So let's talk about what this point is. What's the x-coordinate of this point? X. What's the y-coordinate? Well, if this is the function f, right? If this is the function f, then it would be whatever you get when you plug x into that function. So I'm going to call that f of x. Right? You plug in x into that function, the output, the output comes out, right? Y'all yes? Yeah? Okay. Now, what about this point? The x-coordinate of this point is what? X plus h. And what comes out of that function when I plug x plus h in is whatever the function does with that x plus h, right? So this x-coordinate is x. The y-coordinate is what you get when you plug x into the function. This x-coordinate is x plus h, and the y-coordinate is whatever comes out. All right, that's it. So what's the slope of the line? The slope of that red line would be this one minus this one, right? F of x plus h minus f of x. That's the y2 minus y1 over, what's x2? x2 is x plus h minus what? X. And do y'all see that the x's go away here? And you just get this right here. This is a generic formula. This is a very generic formula right there. It's a very important formula. It's called the difference quotient. So this formula right here, that formula will always give you the slope of this red line, all right? For any function. So now I'm going to give you one specific function. What if I give you this function? Let the function we're talking about be the function 1 over x squared. I'm just making this up, all right? 1 over x squared. I'm going to graph it for you so you can see it. I'm going to graph it on Desmos. Have y'all heard of Desmos? Okay, if you haven't, you should look into it. It's a website. You can graph things. This red graph right here is the graph of that function 1 over x squared. Right, there it is. And if I were to take any 2 points on that function, let me go ahead and put a point on here. Let me do the point 1 comma f of 1. See that blue point there? And then I'm going to take another point. Let's make it 1 plus h comma f of 1 plus h. I think I'm missing something there. See that second point? You see that second green point? Okay. What I'm going to do is try and come up with a formula that would give me the line between those 2 points, right? So to do that, I'm going to use that right there. Okay? I'm going to use this right here. So what would happen if I plug x plus h into that formula? What would I get? If I ask you to replace x with x plus h, what would you get? 1 over x plus h squared, wouldn't you? Minus, okay, now what happens, what's f of x? What's f of x? 1 over x squared. Okay, and then all of that is being divided by what? H, right? You all agree that this generic formula that gives you the slope of this line for that function would be that? Yeah? Now, that's the same as this, isn't it? Could I take that h and flip it like this? Keep dot flip like we just talked about? So you'd have a 1 over h out here? Okay, go look at the problem we just were asked to do. Where is it? Do y'all see it? Do y'all see the problem we just did is that? Number 74. If I flip this, right? If I flip this and bring this up as 1 over h, multiplied, I'll be multiplying all of this by the 1 over h, right? This is gone. So what that problem is just putting that 1 over h in front. You see? So what we're doing is we're preparing you for the type of algebra that you're going to be needing to do in calculus. So why do we want to do this in calculus, right? Why do we even want to find the slope of that line? So I want to go back to the graph and show you something. So I need to do one thing. Hold on, I need my glasses for this. All right, so I'm going to graph a line. Y minus f I'm missing something, hold on. No. All right, there we go. You'll see that picture? I'm going to have to go over here to the board and demonstrate, or to the thing and show this. Do y'all see that I could connect a line between these 2 points? Yes? And that we should be able to do that, right? We should be able to do that wherever, no matter where that green dot is, we should be able to connect them with the line, shouldn't we? But what if I make that green dot, move? How about right, oh man, it's hard to do. Right there, can I still connect those with the straight, or with the line?
Yeah.
But what if I put the green dot on top of the blue dot? Can you define a line anymore? No, because you have 1 point, right? Don't you need 2 different points to define a line? Yes? So in calculus, we ask ourselves, is it possible to find this line right here? That line, I can't get it to stay. 1. Do y'all see that, that black line right there? That is called the tangent line to the function. Can we find that line? That's what calculus is all about. Can you find that line that touches the graph at 1 point and 1 point only? The whole class, that's what it's about. So it's a pretty simple idea, but we have to be able to do this, and then there's something else we do as well. But if you can't do the algebra, you're not going to be able to do the calculus, right? Yes?
Is that what Cal 2 goes into also?
So the process of actually doing this, okay, it's called finding the derivative of the function. Okay, that process is called differentiation. So calculus 1 is about this thing called differentiation. Okay, Cal 2 is taking that process and going backwards. So basically in Cal 1 you learn how to walk forward, and in Cal 2 you have to like moonwalk back, and Cal 2 is much harder than Cal 1. Much harder, but you can't even, there's no chance of being successful in Cal 2 if you're not successful in Cal 1. And this is just a warning to all of you, because I told you I teach the whole sequence, right? It's a warning, it's a motivational warning, all right? I tell all my Cal 1 students that if you come out of Cal 1 with a C and you need to take Cal 2, go take Cal 1 again, okay? Your chances of passing Cal 2 with a C in Cal 1 is like this, all right, really small. My A students in Cal 1 struggle in Cal